So we have seen the vertical circular motion. So now we're looking at few things actually. Let me just take a second and put the diagram. Okay, so we are looking at few points over here. So we're going to make use of the formulas. The tension in the rope in general is m by r, gr plus u square. This formula, I have it in front of me. I'm just looking at it and writing. And then we have the velocity at any given point is u square minus 2gh to the power of 0.5. So this is your generic scenario, right? So now the critical point is at h, at point h. So we have th is equal to m by, so what will happen, m by r will remain the same, that is constant, gr is the same, that is constant, u square will not change. So what will change? Yes, minus 2, minus not 2, sorry, 3 into g into h will change. If this is 0, 0, this is how far away? This is diameter. Why am I talking to you guys as if you are in 6th graders? You guys are not 6th. So this is 2r because it's diameter. So m by r, and this will reduce to 5 u square minus 5 gr. So that will be the velocity at point h, sorry, tension at point h. Now let's look at the tension at the bottom L. So now at L, okay, point L. So these are all to do with tension. At point L, how will things change? So T of L is equal to m by r, this will not change, gr will not change, u square will not change, this will become 0 though, right? And that is your expression. So you can see the tension is, yes, higher at the bottom compared to the top. Now let's look at the difference actually. Let's look at the difference. So difference in tension between TL and TS, that is. So TL is of course greater, that I actually explained, I should have asked you guys. So m by r is common, and this is gr plus u square. I think of course there also you have minus u square, and this becomes plus 5gr. So this and this will get cancelled, and we have 5g, actually not 5, sorry, 6 gm. That's significant, right? 60 times of the mass of the object. That's the difference in tension. It makes sense. When it's coming back and coming down, that velocity will be there. That pull will be there from the gravity, and also we also will be swinging it around, right? So that it's pretty huge. Okay. So this is one thing. Next is, this is all to do with tension actually. So let me divide the discussion. This was all to do with tension related. Next we'll do with, we are looking at velocity related. Okay, so velocity related, what we are looking over here is, this is actually pretty important actually. For me, and I find this interesting. So first thing is, we will be looking at minimum velocity of the projectile or the object of the mass at lowest point so L for something called as looping the loop. So what should be that value so that I don't have to I should not be putting extra effort. I'm pretty lazy. I don't want the object to go in this manner and drop down like this. I want it to go full-fledged to this point and then take the entire loop and come back. Again, it should not go anywhere and slow down and fall down. It should not be the case. I don't want that. So what is that velocity with which we need to work with so that we have an entire round thingy? I mean, basically it's going around. It should not fall any point of time. Okay. For that, what is the velocity? That is your looping the loop. It has to go loopy loop, one entire circle basically. So how much velocity should the object have so that it goes round and comes back? Okay. So that's what we are trying to figure out. So basically the body will be able to actually cross the point H, right? That is, so there without any, the condition is without any slacking. Slacking is the thread getting loose per se of the string. So basically TH has to be a positive value. So this is your clue. Now basically TH is greater than or equal to 0. Again, what we have is an expression m by r, same expression we are using again and again. So at the top we already have the expression u square minus 5gr. We just derived it, greater than or equal to 0. So if I transpose u, okay, all this you guys can understand. U square should be greater than or equal to 5gr, or you can tell u is greater than or equal to root of 5gr. That's it. So that should be the velocity which makes the object go loopy loop. Right guys? Next is minimum velocity at the top. Again, for it to go loopy loop. So for that, so we'll start off with the expression VH is equal to v square h is equal to u square minus 2gh, and at h this is 2r, and we have for no slack we have the condition that u square is equal to, we just wrote it, 5gr, right? Okay, so if we substitute, therefore v h square is equal to 5gr minus gr basically. So the velocity at the top will be root of gr. So this is also known as, oh sorry, I meant to draw this, aka critical velocity. Actually it can't be equal per se. Okay, let me come back to this original point, starting point. So we saw that unlike our traditional circular motion, wherein we just spoke of things moving along a surface, horizontal surface, a bit of bending and all that we saw. It was quite simple, straightforward. We saw your centripetal acceleration and centripetal force. Here we didn't see much of tangential acceleration, but that is the one which will vary the speed of the object going in circular motion. So all of that is something that you guys should be familiar by now. Now we are looking at a scenario wherein the object is getting influenced by gravity at every point of time. That is, we're looking at a scenario wherein the object is going in a vertical plane. Right? So this has to be the natural next step for us to take. So we saw we have to get a general expression for the tension and the velocity at any given point of time. That's the basic thing that we need to understand any, to talk about anything of this nature. Those are our fundamental understanding: force and velocity. Right? Everywhere it's the same. So we are expressing in terms of height, because height is the one which will vary. Because of height, the gravitational potential energy changes, and so the kinetic energy changes, and with that your velocity and what else, tension and everything changes over here. So we got exposed to those expressions, and those expressions I have written over here. Now we are just picking up specific cases. Very simple. At point H, what is the tension? At point L, what is the tension? Okay, and then we are looking at, I want to see to that the object goes one round. What should be the velocity at the bottom? What should be the velocity at the top? That's what we went on exploring. And that was your derivation. And now you can pause and have a look. So this is B, by the way. Yeah, that's it.